To define the 6 trigonometric functions, we will need a right triangle. So here we have it, and in this right triangle, one angle is the 90-degree angle, and the other two angles are acute angles. Let one of these acute angles be angle theta. Then in this triangle, the side that is opposite the right angle is the hypotenuse. We will call it side C, then the other two sides will be A and B. Now, if we consider angle theta, then this side A is the side that is opposite or across from this angle theta. And side B will be the side that is adjacent to this angle. So again, in this right triangle, the longest side is the hypotenuse, and for this acute angle theta, side A is the opposite side and side B is the adjacent. Now let's talk about the 6 trigonometric functions. These functions represent ratios of two sides in a right triangle. The first trigonometric function is the sine function. To write this function, we use this abbreviation SIN, and next to it we write angle theta. And we read this sine of theta. Now to find the value of sine of theta, in this right triangle we have to divide the opposite side by the hypotenuse. So we can write that sine of theta is the opposite side divided by hypotenuse. And in this right triangle, that is A divided by C. And it's important to understand that for this specific angle theta, no matter how big or how small this triangle is, this ratio of A to C will always be the same. But if angle theta changes, then the ratio of A to C also changes. So the trigonometric functions change their values if angle theta changes. Now the next trigonometric function will be the cosine function. We write this function cosine of theta, and to find its value, now we have to divide the adjacent side by the hypotenuse. So we will write adjacent divided by hypotenuse, and in this triangle, that is B divided by C. And again, this function changes its values as theta changes. And now the next trigonometric function will be the tangent function. We write it as tangent of theta, and we find tangent of theta by dividing the opposite side by the adjacent side. And this will be A divided by B. So again, here we have three trigonometric functions, and the first one is sine, and sine is the opposite side divided by hypotenuse. Cosine is the adjacent side divided by hypotenuse, and tangent is the opposite side divided by adjacent. Now let's talk about the rest of the trigonometric functions. They are called cosecant, secant, and cotangent. We write the cosecant function using the abbreviation CSC, and we read it cosecant of theta. This function is the reciprocal of the sine function. This means that if the sine function is the opposite divided by hypotenuse, then the cosecant function will be the hypotenuse divided by the opposite. And if the sine function is A over C, then the cosecant will be C over A. So this is equal to C over A. The next trigonometric function is the secant, and secant is the reciprocal of the cosine function. We write it as secant of theta, and if the cosine function is the adjacent divided by the hypotenuse, then the secant will be the hypotenuse divided by adjacent. And it will be equal to C divided by B. As you see, we get the reciprocal by flipping this fraction. And now the last trigonometric function is the cotangent, and the cotangent is the reciprocal of tangent. The abbreviation for cotangent is COT, and we read it cotangent of angle theta. And if tangent is the opposite divided by the adjacent, then the cotangent will be the adjacent divided by the opposite. And it will be equal to b over a. So now we have all 6 trigonometric functions, and they are sine, cosine, tangent, cosecant, secant, and cotangent. Now let's see an example on how to find these 6 trigonometric functions given the sides of a right triangle. Here we have a right triangle with side A equal to 4 units and side B equal to 6 units. We will use the Pythagorean theorem to find side C. Then, once we know all 3 sides, we will find the values of all 6 trigonometric functions of angle theta. Now, from the Pythagorean theorem, side C is equal to the square root of a squared plus b squared. From here, side C equals square root of 4 squared plus 6 squared. Then 4 squared is 16, and 6 squared is 36, and 16 plus 36 will be 52. Then C will be equal to square root of 52. And we can simplify this by writing 52 as 4 times 13. Then square root of 4 is 2, and we will have 2 times square root of 13. So as you see, when we simplify a radical, we write it as a product of 2 numbers where at least one of the numbers is a perfect square. Then once this number is a perfect square, then we find the square root, and in this case we get 2. Now let's add to the triangle that C is equal to 2 square root of 13. And now once we have all 3 sides, we will find the values of all 6 trigonometric functions. The first one will be sine of theta. And by definition, we know that sine of angle theta is the opposite side divided by hypotenuse. That is A divided by C. And in our triangle, A is 4 and C is 2 square root of 13. Now we need to simplify this fraction, and first we will divide the numerator and the denominator by 2. So 4 divided by 2 is 2, and 2 divided by 2 is 1. Also, we need to rationalize the denominator, and this means we have to eliminate the radical from the bottom. For this, we will multiply the numerator and the denominator by square root of 13. Then in the numerator we will have 2 square root of 13, and in the denominator square root of 13 times another square root of 13 will be 13. So this is the value of sine of theta in this triangle. Now let's find cosine of theta. By definition, cosine of theta is the adjacent side divided by hypotenuse, and that is b over c. Then b will be replaced with 6 and c with 2 square root of 13. Now we will divide the numerator and the denominator by 2, and just like above, we will multiply the numerator and the denominator by square root of 13. We do this to eliminate the radical from the denominator. Then in the numerator we will have 3 square root of 13, and in the denominator we will have 13. And this is the value of cosine of theta. The next function will be tangent of theta. By definition, tangent is the opposite side divided by the adjacent side, which is a over b. We will replace a with 4 and b with 6. Then, if we divide the numerator and the denominator by 2, we will get 2 over 3. And because here we did not have any radicals, simplifying this fraction was much easier. So the value of tangent of theta is 2 over 3. Now let's get the rest of the trigonometric functions and we know that they will be reciprocals of these three functions. The reciprocal of sine is cosecant, and cosecant is c over a. C is 2 square root of 13 and a is 4. Now we will divide the numerator and the denominator by 2. Then cosecant of theta will be square root of 13 over 2. The next function will be secant of theta, and we know that this one is the reciprocal of cosine of theta. So if cosine of theta is b over c, then secant is c over b. Now let's replace c with 2 square root of 13 and b with 6. Then we will divide the numerator and the denominator by 2, and secant of theta will be equal to square root of 13 over 3. And now the last trigonometric function will be cotangent of theta, and this one is equal to b over a. From here we can replace b with 6 and a with 4 and then simplify the fraction. But whenever is convenient, we can just go and take the result of the reciprocal function and flip it, and in this case we will get 3 over 2. So cotangent of angle theta is 3 over 2. And now we have the values of all 6 trigonometric functions of angle theta. I hope you enjoyed this video. Please leave a comment, subscribe, and thank you for watching.